Well, this is Gilson, Illinois, and farmer Bob Wolf's driving his cattle truck down the road there in Gilson. And you know notice anything out of the ordinary with his truck?
He's,
How about the front wheels?
he's going four-wheeling.
Anyway, how do I get rid of oh, here. Okay, here we go. Anyway, he saw a train go by with these really fat wheels on it, and he thought, well, I'll try the same thing on my truck. Well, it looks kind of weird, but it really works good in boggy ground, and at least with the front axle. I guess what he ought to do is put dualies on the back end too. But anyway, this is kind of one of my pet peeves in the hobby is you got beautiful models like this tangent hopper car. Everything's almost exactly to scale, except for maybe the trip pin on the Katy coupler. And then you look at the wheels and I go like, anyway, to each his own, but it's my thing. I really like having closer to scale wheels on my models. So I've done some things about it. I've got most of my fleet equipped with Code 88 wheels now. I mean, if I was starting over again, yeah, maybe I would go to fine scale or even with Code 88s, I could change the back-to-back on the wheels. You know, they wouldn't look quite like this. You know, I don't know if you guys know, but a freight car wheel's 5.5 inches wide from the back to the front here, and the Code 110 wheel is about 9 5/8 inches wide, so it's almost twice this. You know, the wheel would probably be out here somewhere in the side frame. So getting back to what Ken was saying about RP25, this is a August 75 model railroader, and then had several articles in here about doing things closer to fine scale, including wheels. Now this was the article here, and it was written by Malcolm S. Cross. You guys probably don't know anything about him, but he was one of the forerunners over in the UK when they started the Proto Force Society, which is a scale force society now in England. And they wanted to model things as close to scale as they could. So in the picture here on the top wheel there, that's a 4mm scale 4 wheel, and God, I don't know what this thing is on the bottom. It's probably something from River Rossi or some European model. But you can also see the difference in the track here, and it's probably Atlas on top, and that's some 4mm P4 track on the bottom there. So anyway, that's kind of my goal, is to make things on my layout look a little closer to scale as far as wheels go. I even the other day I even wanted to wrap my head around this whole thing, and so I thought, well, I'll blow up the profiles here. I didn't put the little fillets in here like well, I got little bitty fillets in here. They're probably not big enough, but so I blew up the NMRA standards like 10 times. So I think HO is what, like 0.5 some 0.65 something gauge. So this is about 6 5/8 from, this is the left-hand rail, this is the right-hand rail here. And this, I drew everything what the target dimensions were for the NMRA. So I used the target back to back. I used the the target gauge here. This would represent a guardrail, and this would represent the running rail. And likewise over here, this rail on the inside would represent the point of a frog, and the outside rail would be the running rail. So this would be this flange would be going between the running rail and the frog here. So and the wheel width here is a 0.110 or 110 wheel sets. And where I put the red line on here, that's where a code 88 would be. So basically by taking 22 thousandths off or going from 110 to 88, this represents about 2 inches of scale. So if you took another 2 off, say what? Go ahead.
No, nothing.
Oh, yeah, but so if you took another 22 thousandths off, you'd be pretty close to scale, but the flanges are just huge. So that's mainly what's holding you back from making finer scale track. Now code 88 wheels, like some of the manufacturers leave the 30 thousandths flange on them, and some of them like KD and I think Tangent and I think North American Railcar out of British Columbia, they all have 25 thousandths flanges, like what's recommended through the NMRA through their finer standards. And if you made all your track to code 88, with the 25 thousandths flanges, you could make your track look a lot finer. You could have a lot smaller space between your guardrails and your running rail, and same thing with the frog. You could almost get pretty close to what things would look like in a P87. So here's kind of what I'm doing. In some cases, well, I've got code 88 wheels you could buy off the shelf. And some cases the manufacturers don't make them. Their axle diameters are different, or they don't. You can't swap trucks between them and that sort of thing. So what I've got here in the cream cheese cover is a code 110 equipped truck on the right side here, and a code 88 on the left that I turned down the wheels of. And here's a set of code 88s that I turned down in my lathe. Now, if you want a real example of scale, I mean, this big truck here, that's a P48, in other words, O scale, but correct gauge wheel. And, scale wheels and flanges on that, and you put it here right next to a HO truck with code 110 wheels. They almost look like they're the same width. This is a little better shot here. You can see. To me, the code 110s almost look bigger. And here's another example. This upper wheel here is a P4 or 4 millimeter. In other words, it's like O scale, 1 to 76 instead of 1 to 87, but it's the P4 standard. So likewise, these are almost, well, I think they are scale wheels, pretty darn close anyway, next to a 110 here. Here's another example on my layout. There's a car sitting on the main line over here with some 110s on it and some 88s on the left side. There's the 88 thousandths wheels there just to compare, and that's sitting on code 70 track, and this one's sitting on code 100 track, or rail anyway. And those are 110s. So if I want to do it, I mean, not everybody's into this sort of thing. I'm certainly not a machinist, but I guess I could call myself a hobby machinist. But anyway, here's my machine shop squirreled away in one corner of my kitchen. Everybody kind of laughs. Like, you got a machine shop in your kitchen? Well, I kind of have a bachelor pad because my current wife and we got married late in life, and we each had our own house. We each had kids living with us at the time we got married, and we just kind of kept our own houses. Neither one of us has enough room to put each other's crap in. So anyway, I got the machine shop in a nice warm place. This is my 7x19 mini lathe. I don't know. I imagine a lot of you are familiar with machine tools, and this is the the chuck over here on the left and the tail stock over here. Right now it's got a drill chuck mounted in it. And this is the carriage in the middle. The big black wheel here makes the carriage go to the left and the right. And this crank right here runs the not the compound, the cross slide to make the tooling go crosswise to the carriage. And then over here on the right is the way I've got the compound. This is the compound here that holds the tooling, and this crank here, the way I've got it set up right now, it'll make the tooling go parallel, back and forth, parallel with the carriage of the lathe. I mean, you can set the compound up at all different angles, so you can make tapers and that sort of thing. One thing I dabbled in a little bit, you saw some of those O-scale things. Well, I got this from Jay Griswold. I think his name is Griswold in California. He's a guru of doing P48 things for people, and he sent me a couple of these cutting tools for reprofiling O-scale wheels in a P4. And I turned a couple of these down. This is an old Atlas O-scale boxcar that I converted a P48 with. Yeah, this was an old Walthers truck, probably from the late 70s or something, and it had big fat O-scale wheels on it. And I turned those down to P48 standards with that cutting tool. Here's another shot. You can see how skinny the wheels are. Anyway, I have also re-wheeled a Atlas F9, and boy, when you put the wheels on there, they look like quarters. All right, here back to the lathe. Let's get going here and machine down a wheel set. Here you got a Code 88 wheel set that's already been turned, and a 110 wheel set. And now, in order, you got to take the at least one of the wheels off the axle. Usually the wheel set that has the plastic bushing in it to create some insulation between the two wheels. So you have to have something to hold the wheel that's all by itself. Well, here's a wheel that's already had the plastic bushing removed from its center. So what I have here is what I call a mandrel. I don't know if that's the right term, but that's what I'm going to call it. Anyway, it's made from a 832 brass screw with an 832 nut. It's got a piece of I think 3/16 copper tubing, and one end of the screw has been turned down so that it's a snug fit in the inside diameter of the car wheel. And here's the assembly again with a wheel slid on. You know, once this gets chucked up in a lathe here, you know, with the whole assembly snug, this nut gets turned and it pushes the copper tubing down onto the wheel to hold it in place so it doesn't spin while you're machining the thing. And it works pretty good. Yeah, here's the raw material you need to make a mandrel. There's a 832 screw from the hardware store. It's 2 inches long. It's brass. It's got a nut on it. First thing you have to do is remove the head here so you can turn one end the screw down in the lathe to the right diameter for the inside wheel diameter. So here I've got the screw chucked up in there, and I just finished machining the head off the thing. Now, I got kind of ahead of myself a little bit here. I've got the tail stock in here, and what I had to do before I chucked the screw up in here and started machining it was take a center drill, you know, and mount that in the tail stock, bring it up to the end of the screw and drill a little hole in here to make a cone shape in there so it fits in the tail stock. If you didn't have the tail stock here when you're machining the screw is either gonna like bend like crazy or it's gonna just break off. So that's the way it is. Okay, here's another we're a little further along here. We got the tailstock and the dimple in the end of the screw, and we're machining the thing down to the right diameter. You have to keep checking it to make sure you don't go down too far, otherwise you got to start all over again. Oh yeah, here's what I was talking about, putting a dimple in the end with the center drill mounted in the chuck mounted in the tailstock. What I also do is for driving the axles out of the wheels is take a little, I don't know how big a diameter it is, probably a little over 1/8, and putting a dimple in it to facilitate driving the axle out of the wheels. So there's the finished product. We got one mandrel for whatever size wheel you had. Like I said, all the manufacturers don't have the same diameter inside the diameter on their wheels. So if you run across something different, like I do, you got to make a new this part anyway, or this part right here. So it fits as a nice snug fit in the inside of the wheel. There's two different ones there. You can hardly tell, but one's bigger than the other one is diameter wise. Here's the thing I'm starting to mount it in a chuck here. You got the skinny part of the screw that's been machined down, with through the wheel into the chuck there. And then what you do is you just shove the whole thing tight up against the chuck there, and this copper tubing slides up against the wheel. You tighten the nut down against it, and you're ready to start machining. This copper tubing will keep the wheel from spinning. When you're doing the axle side, it's real easy. All you got to do is stick the axle in the chuck up tight against it, and bring your tooling over there and go to it. If you want to know how long it takes for like one car with 2 trucks and 8 wheels, it takes pretty close to an hour. I think I could get it done a lot quicker if I was doing production. If you just do one operation, just solid all the way through, and then do the next operation. And there's another view of the same thing. Yeah, there's the finished product again. Okay, now here, I use my milling machine and more of a press as a press than anything for doing this sort of thing. Here I'm getting ready to, and well, I've got the wheel set mounted between the 2 parallels here in my vise, and so there's enough clearance under here that the whole wheel set clears by plenty. But here I got it mounted in here. What I'm going to do is bring this is the drill bit mounted in here backwards, and I'm going to shove the axle at least part way out of the wheel here. Well, I found out real quick this is not the way to do it. Because you got hard hard high-speed steel here going against the soft axle. That doesn't work too good. So I wrecked the first one. And I learned from that. That's when I started making the brass rod with the dimple in the end. So that works real good now. I haven't wrecked anymore. Yeah, getting back. Yeah, it's just showing cutting the dimple in the end of the brass rod. Now I'm doing it the right way. Now I got a brass rod in there. It has a cone-shaped dimple in the end here that pretty much clears the end of the axle, and you can see this wheel still has its plastic bushing in here for insulation. So then I just get it between these steel parallels here, bring the whole thing down on top, and start shoving the axle out. You don't have to shove it all the way out, just part way. Most of the time it's loose enough by then. You can just pull the wheel off the end of the axle with your fingers, like in this view right here. And you can, I think this is a scale trains axle, which was different than the exact scale axles and probably different than the tangent ones, but anyway. So anyway, you pull this off and sometimes the bushing will come along with it, sometimes it won't, but this bushing's shoved off here far enough, it'll probably come out too. Sometimes the wheel will, depending on what brand it is, will come out with the bushing still in it, like this one here. I think this is an exact scale wheel. This has got the plastic bushing still in it, so that means one more operation. So you got a couple wheels here ready to press the bushings out. And then it's just a matter of finding the right size drill bit that's a little smaller than the hole in the wheel here. And just mount this over one of the holes in a parallel here and just shove the bushing out. Usually they plop down in between my vise here, but they get captured in there, so they don't go flying in outer space like a lot of things. I'm sure anybody that's done any modeling knows about that. All right, now I got the bushings out, so I'm ready to start turning some wheels. That's that. Oh, okay, this is a wheel with an axle in it. I'm turning that down. And here I'm using a tool that's got a carbide bit on the end of it. I found out I've come up with a much faster way of doing this. Yeah, what I do now is like, well, kind of like what I'm doing here. I'll get the chuck rotating and come up against the wheel and touch off on it, and then I'll set the dial on my tool to take 22 thousandths off, and then so in other words, the compound will advance the tool 22 thousandths toward the chuck, and then all I have to do is bring the tooling back in against the wheel, and it'll automatically take 22 thousandths off and go from 110 down to 88 thousandths. The tool I'm using right here is my favorite kind here. I think I'm gonna go with all those from now on though. It's just a high-speed steel, a bit that you grind yourself on a grinder. There's all kinds of different tooling you could make yourself on a grinder if you practice a little bit. Yeah, this is the setting on the compound, set at well, you have to zero it in first, make sure there's no backlash in the dial here, and then set it for 22 thousandths and crank it down to, well, you start at 0 actually, and then you crank it down to 22 thousandths, so you're advancing the tooling toward the chuck, and you're all set to go. And once you got the wheel turned down, I check the width in the caliper here, and if I'm lucky, most of the time I am now, but as you can see here, it's 88 thousandths wide now instead of 110. So that was a success. Next thing to do is to shove the axle back on the wheel with the bushing. And here, that's what I'm doing. Sometimes you can stick the bushing on the end of the axle and then start it in the wheel by hand, and then mount it in the vise here, and then bring that brass rod down on top of everything and shove it in there. Now, you got to check the back-to-back gauge on these things after you do that, because they're likely not to be perfect. So there I am checking the back-to-back on it. With 88 thousandths, I'm a little more generous with the back-to-back because, you got thinner flanges, and you're moving the wheel out. Actually, if you were if you had a layout with all 88 thousandths wheels on it, the minimum the NMRA wants you to make the back to back is 581. This is like 578.5 thousandths. Yeah, and then you could make all your track conform to much finer standards. Yeah, one thing I do after I complete the trucks is give everything a roll test. You know, put the wheels back in there, and I kind of learned this from watching a video on the La Mesa Club's car department guru. His name is John Cathcart. I think he's still there. Anyway, he's got a 1 hour long. Well, he's got a 5 minute long video and a 1 hour long video on maintaining all the cars on the La Mesa Club with his 28 miles of scale mainline track with heavy mountain grades. They run 60, 70 car trains on there regularly. Some are even longer than that. They wear locomotives out and they run for the public. So everything's got to be up to snuff. And one of the tests that he does is a rolling test. Yeah, this is a 2% grade I've set up here kind of permanently, and his hopper car is flunking the test right now because it's not rolling down there on its own. So I've since remedied that. I mean, it's what they do. The guy does at La Mesa. Maybe some other people do it too, and probably you guys do. But you know, if the wheel doesn't roll real good in a wheel set, I mean a truck, you can take a pliers and you know, it can grab the truck frame and really give it a twist to the outside and then put the wheel set back in there until it rolls freely. I mean, the test they do, they want the wheel to keep spinning for at least 20 seconds or something like that. I'm happy if they run for 10 seconds. The other things you can do too is waiting and you know, make sure the trucks swivel well. You know, there's no binding in the trucks. At La Mesa, they're real strict about their draft gear and all that too. Pulling such long trains, there's got to be quite a force on their drawbars. Yeah, one thing I'm doing, you guys might laugh, but this is one thing that Mike Confalone does on his car fleet. He adds a lot of weight. Well, I might not go as far as he does, but this is a 1/2 steel bar sitting on top of this boxcar, and it probably weighs about 3.3 ounces. So I'm getting this car up to between 7 and 8 ounces total. So, but boy, they really roll good, and all the grades on my layout are pretty doggone flat. I don't if I have any 1% grades, they're not very long. So, you know, one 6-axle locomotive on my layout can pull quite a few cars. I mean, I've got some 30-car coal trains, and I think one locomotive could do that. I put 2 on, but I think one could do it. Another thing I've been doing, I have fewer and fewer cars that have 110 thick diameter, not diameter, 110 thickness wheel sets. Is mark the cars that still have 110s on them. This is kind of similar with I think it was the FRA did back in the 70s when they were checking for bad wheel sets. You know, if a car doesn't have the proper wheels on it. Well, mine's a little different. If it doesn't have the proper wheels on it, I put a yellow sticker on them. So just kind of to annoy myself, to remind me to get this car up to my standards. I've been reading a couple things over the past year or two, and one really cool find, I think, at least I think it's really cool. This is a 435 page volume on Modern Derailment Investigation by Gary P. Wolf. And I think Dave said he might give a talk for the NMRA or something. Do I have that right or not?
No, we're hoping to have him talk to our local National Railway Historical Society.
Oh, okay. Okay. Anyway. Yeah. Well, anyway, Gary is, he started out in Lionel when he was a kid and he advanced to the real thing, and he's made a 50-year profession out of investigating derailments. And this book is a real eye opener, I'll tell you, because it goes into, it's kind of scary in a way, but it shows you everything that can go wrong to cause a derailment. And you know, one of the main things they deal with in real railroading, and well, actually it applies to model railroading also, is the LV ratio, which is the vertical downward force. In other words, the weight of the car and its lading on the rail, as opposed to the lateral force, which you might incur when you're going around a curve with centrifugal force, or if the track is tilted like super elevation. You know, the lower rail is going to have a lot more lateral force on it. So once this ratio, it can go up to about 80%. You know, when the lateral force becomes 80% of the vertical force, you're almost going to have a derailment for sure, because that flange is going to ride right up over the top of the rail. Yeah, I found something else interesting when I was looking through old John Armstrong articles from the early 70s. He had almost the identical diagram here with the LV ratio, with the vertical force pushing down on the rail and the lateral force on the rail. There's all kinds of things that can go wrong. One of the you know, I don't know if you guys know it, but a tie plate actually cants the wheel, the head of the rail in toward the inside of the track a little bit. But railroads have to deal with things like tie plate wear, where, you know, from trains going over and over and over the track, the tie plates actually start eating into the tie, and you can actually get a reverse cant on the rail from that in some places. And you know, if the tie plate kind of starts to bury itself in the tie. So luckily we don't have those things to deal with. Another good book that I read in the last year was Ian Rice's Fine Scale Track. This is mostly for the P4 guys over in the UK. A lot of it applies to HO though too, if you lay your own track. And it's kind of enlightening about all the different jigs they use and stuff. You know, so they can keep pretty fine standards with their little skinny wheels and still have everything run great, you know, as long as you take care with the track and laying it out, using the jigs to make everything come out right. So that's the end of my talk. And that's the end.
Very nice. Thanks, Ken.
Any questions, anybody?
Ken, this is Dave. Do you ever have problems with the bushings like crumbling or cracking?
No, they're all the ones I run. I'm surprised, but you know, because you know, model diesels have those problems with the gears cracking and all that. I haven't. I've taken apart some pretty old ones that, you know, where they were all painted and everything already, and they seem really resilient, which is a good thing. One thing I did recently was take apart a Kadee wheel set. Well, they're kind of not real friendly to taking apart and doing things with the wheels, although I think you can. But I drove the axle out of one of the wheels, and then I thought, well, I'll just try this. It might work, it might not. So I chucked up the plastic axle in the chuck of the lathe, and it brought the tooling onto the wheel, and the axle snapped off right away. So that part was pretty brutal. So I think if I was going to turn down any Kadee wheels from 110 to 88 thousandths, I'd have to use my little man both wheels. What was that?
So most of the axles, Ken, are metal axles? over
Yeah, yeah. I mean, yeah, I don't deal with any plastic ones.
Okay,
Like I said, you probably could turn down the KD wheels. I mean, the KD wheels are pretty good. At least the 88, their 88 thousandths wheels have 25 thousandths flanges on them, like a 88 thousandths wheel is supposed to be. I run across some other brands that have 88,000 wheels, but they still put a 30 thousandths flange on them. Now, as far as manufacturers go, I've talked to several of them because except for one manufacturer, what they want you to do is they want you to buy the cars like they are with the 110 wheel sets on them. Well, I said, well, why can't you? You got the 110 wheels. You even sell the 80 or the 88 thousandths wheels. You even sell the 88 thousandths trucks, complete. Why can't you just put some 88 thousandths on some of the cars? Oh, no, you can't do that. And I talked to one manufacturer recently at our train fest, and he was like kind of like in disbelief that I could run 88 thousandths wheels on my track. But he said, "Well, you must lay your own track." Well, yeah, I have, but laying your own track is sometimes not as easy as using prefab track because that's made in the factory and everything like that, and the tolerances are pretty close.
But you
But,
told me it runs through your Atlas turnouts. too.
Yeah, 88. Well, I mean, you saw my sketch in the beginning. I mean, jeepers. I don't know if we go back to that thing, way back here.
while you're looking, how about gauging? Do you just all twist the wheels in the gauge if they're not exact by hand then? Because of the.
Oh yeah, for sure. Yeah, I mean, I have gauges for like P4, what the UK they use in UK. What they make a real simple back-to-back gauge for theirs. What they do is they take a piece of mild steel, a piece of angle that's steel, and then just machine it so it maybe it's as long as whatever the back-to-back is, and they make sure everything's true and square, and you just set the wheel set inside the angle, and voila, you got it set. I mean, yeah, if you use that, you can use the NMRA gauge too, and just set everything to NMRA standards. I don't know if everybody knows how to use one, but the check gauge, which is the distance between the back of the wheel and the flange over here, what would you call it? The outside of the flange, and I guess you'd call this the inside of the flange, maybe. I don't know. But anyway, that's when you put that in the NMRA gauge, you push this flange here tight against that little groove there, and this side of the flange over here is supposed to be tight in the other groove, So
Yes.
I mean, there's so much slop and tolerance in the NMRA standards. I mean, I was toying with the idea of actually making a couple different drawings of this, and showing like how far, from the target standards you could be and still run trains. But well, like I got the red line drawn on here, and you could plainly see that wheel ain't coming off the track between anything. So, I mean, you could probably whittle it down a little more, maybe. Yeah, there is one manufacturer that actually puts code 88 thousandths wheels on their cars when they come, and that is North American Rail Car in British Columbia. And I remember the first car I got from them, and I thought, wow, these look different. I measured them, and Yeah, they weren't 110s. All their cars come with 88,000 wheels on them. So maybe someday in my lifetime yet, I'll get my wish and cars will come with 88,000 wheels on them already. No, I don't have to do any of this. I guess I wouldn't have to, but that's just
Take all-
me.
They take all the fun out of it for you, Ken.
Well, yeah. I'm not a machinist, but I have a lot of fun playing around with the machine tools. And
Yeah,
I've
that's
done
great.
some real projects. I had a sailboat for a while. I made some pretty big stuff on the lazy pad.
Nice.
And when I lived at home, my dad always had a little machine shop in the basement. He was always doing stuff for one of his boats.
You ever
Machine-
turn down the flanges?
What's that? Yeah, I have actually. I've
Got
had
like 30 to 25,000s?
yeah. What I do then is I like mount the wheel in that mandrel and you know, turn down the opposite side. You don't have to turn the whole wheel down, just the part that's going to be,
Right.
you know, within reasonable contact to the track. So yeah, I've done that. Yeah. It's just another step, but yeah, I certainly can do that. Yeah.
Okay.
Ken, have you experimented with a true scale wheel?
True scale.
I mean, no, an accurate,
Oh,
an exact scale, Proto 87 scale wheel.
no, only in P4, you know, because I started dabbling in that a little bit. Where are we? Let's see, I got to get back in a Zoom meeting here. I lost you guys. Yeah, anyway,
Stop share.
you know, I got to hang on a second. I got to get to the Zoom meeting first. Oh, here we go. Okay, great. All right, I'm back. I'm back. All right.
Very good, Ken. That
But
was interesting.
yeah, what was that question again, Dave? Oh, about
Did you ever experiment with exact to scale wheels?
only with I've got a set of I got a English style, you know, coal wagon right now and a little piece of track, and I've got a couple sets of scale four wheels, and man, they roll great. I'll tell you. I made a piece of track the other day, and I should have a picture of that, but I made a picture of or made a link to P4 track and just put the wheel set on there, and I didn't know my drawing board wasn't level. I put the wheel set on there and it rolled right down the track immediately. So yeah, I'm kind of excited about doing that, a little bit of that on a small scale. Yeah, those guys are something else. I mean, they machine their own locomotive chassis and steam and machine their own connecting rods and put their own motors and gearboxes. And they even do that in N scale. They've got like a 2 mm scale society where they take N scale steam locomotives and machine the driving wheels and everything down to P4 standards. And there's one huge layout over there. It's called something Fields. I can't remember the name of it right now, but it's a really big traveling layout. It's probably as big as 2 ping-pong tables at least, and they run the crap out of these little steam locomotives on there. Some of them actually have 200 actual miles on them. After they go to a demonstration in a hall or whatever, you know, and they'll set up and they'll run the whole weekend. They have to take these locomotives home and clean all the lint out of them because it's amazing how much lint collects in these little locomotives.
Mhm.
Yeah.
Very- David, was there something you wanted to share?
Oh, just if this works, I'll probably have all of Ken's problems plus more.
That's the spirit.
Yeah, there you go.
So can you see an image?
No.
No, nice.
Yeah, there it is.
Oh, there you
go.
go. Oh, that's
Okay.
great. Oh, yeah, there you go.
What I did was I cropped 2 photos so that the gauge would come out the same. Just to prove Ken's point. This is obviously an HO scale model with 80 factory wheels. So those would be the 110s.
Yeah.
The boxcar doesn't matter, but it's an old Silver Streak.
That's cool.
And if this works, that's
Oh.
the same gauge,
That's the real thing.
the real
Yeah.
thing.
Oh, wow. And you actually made the photo so the gauge
And
came out
The
same.
gauge is exactly the same.
Yeah, looks like dimes on the real car.
It does. It does.
Yeah.
So don't scrap your wheels, narrow them like Ken has done.
That's because I'm so cheap.
That's all
Well, I
I
had all
had.
these 110 wheels, and I go like, you know what? Maybe I could salvage some of these things. I had bags of them. In fact, I even offered to sell them to some people really cheap, and they didn't want to take me up on it for some reason.
I will say this, I've learned not to eat food from Ken's kitchen with all those metal shavings.
Yeah, this wharf gets kind of bad sometimes.
So that's all I had to add.
Well, thanks.
Very good. Well, thanks, Ken. That was very interesting.
Sure.
And you know, I may start to have that same hang up, but I'm going to try to avoid it.
Yeah. There's some real prominent modelers out there that still refuse to take the plunge. I know, like Clark he's putting 88,000 wheels on his cars and
Is
stuff.
he?
I don't know if
Okay.
anybody else out there is, but
Most of the guys are at least putting them on tank cars.
oh yeah,
Where
they're
it's very obvious.
yeah.
Hoppers
Well,
are another one. If
Yeah.
you create, much more visible than on a box.
oh sure, yeah. If you got a caboose or something, it's not such a big deal. I've got tons of covered hopper cars and hopper cars and tank cars and that sort of thing. So yeah, it does enhance the look of those.
Yeah.
Yeah.
Yeah. Very good. All right. Well, we will be back at it next week, and Jason Clockey will be presenting on his whatever, I forget what it's called now, Mason City and Clear Lake Railroad. So we'll look forward to that. And so until then, have a great Thursday, and thanks everybody for joining. And thanks, Ken, for presenting.
Yep. Thank you. Good night. Yep.
Thanks, everyone.
Thanks, everyone.
Bye-bye.
Good night, gentlemen.
Good night.